So there's several different ways that we can do multiplication with a vector. But the first we want to talk about is when we multiply a vector by a scalar. So let's take a vector, just vector A equals AXI hat plus AYJ hat. And what we want to do is we want to create a new vector, vector B, that's equal to some scalar C times vector A. So the question is, what's our rule when we do this? The simplest way to think about it is, again, this breaks up into component equations, and of course because C is a scalar, it simply goes with each equation. So what I've got is that the x component of vector B is equal to the scalar C times the x component of vector A. Similarly, the y component of vector B is equal to C times the y component of vector A. And so what that means is that both components of vector A get multiplied by the scalar to give the components of vector B. So if vector A is given by AXI hat plus AYJ hat, and vector B is equal to C times vector A, then the components of vector B are going to be CAXI hat plus CAYJ hat. So let's look at some examples. So let's say my vector A happens to be 3 newtons I hat plus negative 4 newtons J hat. So it points 3 newtons in the positive X direction, 4 newtons in the negative Y direction. And the first thing I can do is I can calculate out, well, the magnitude of that vector is going to be 5 newtons. So just Pythagorize 3 squared plus negative 4 squared, take the square root. And again, in terms of its direction, I can calculate a direction or an angle alpha relative to the x-axis by putting y component over x component in my inverse tangent function. And here what I get is that's going to be 53.1 degrees below the positive x-axis. That's the angle alpha. Well, so let's start by letting B be negative A. So in this case, this means that the scalar I'm multiplying A with is negative 1. And so let's see what happens. Well, if I multiply both components by negative 1, that means that the x component of vector B is going to be negative the x component of vector A, so that's negative 3 newtons. The y component of vector B is going to be negative the y component of vector A, negative 4 newtons, so again those two cancel and I got positive 4 newtons. So if I think about vector B, it's going to be negative 3 newtons I hat plus 4 newtons J hat. So the magnitude of that vector is 5 newtons, the same as the magnitude of vector A. The direction of that vector, it happens to make an angle beta that's 53.1 degrees above negative x. So what we see is vector A points in the direction 53.1 degrees below positive x. Vector B points in the direction 53.1 degrees above negative x. So you can see that vector B has the same magnitude as vector A. It points in the opposite direction. Let's make another vector. So vector C is equal to 1.5 times vector A. So now my scalar here in creating this new vector is 1.5. And again, what I'll emphasize is that that just happens to be a positive number. So I'm going to multiply both components of vector A by positive 1.5, which means that the x component of vector C ends up being 4.5 newtons, or the y component of vector C ends up being negative 6 newtons. So vector C is 4.5 newtons I hat plus negative 6 newtons J hat. So again, if I think about the magnitude and direction of vector C, well, if I Pythagorize to get the magnitude for vector C, what I notice is that 7.5 newtons, so 4.5 squared plus negative 6 squared, take the square root, I get 7.5 newtons, which is 1.5 times the magnitude of vector A. So we said vector A was 5 newtons, 7.5 happens to be 1.5 times 5. So the direction, again, I'll think in terms of some angle that I'll label gamma here. This direction, I get the inverse tangent of y component over x component for vector C, and what I notice is it's 53.1 degrees below the positive x-axis. So what this means is that vector C is larger in magnitude than vector A, but it points in the same direction. Let's look at one last option. So vector D is negative 1/2 times vector A. So again, my scalar here that I'm multiplying vector A by is negative 0.5. Well, again, I know that I'm going to multiply both components by negative 0.5. The x component of vector d is going to be negative 1.5 newtons. The y component of vector d is going to be positive 2 newtons. So again, when I draw in vector d, it's the vector negative 1.5 newtons I hat plus 2 newtons j hat. And so again, thinking about that vector, its magnitude ends up being 2.5 newtons, which happens to be 0.5 times the magnitude of vector A. The direction, again, I'll define some angle delta relative to the x-axis here, and so the direction that vector d points is 53.1 degrees above the negative x-axis. So again, what I see here is I've got a vector that's smaller in magnitude than vector A, but points in the opposite direction. So how can we summarize what's going on here? So if I want to think about the direction vector B points relative to the direction of vector A, the sign of that scalar C is going to tell me what I need to know about direction. So if C is positive, if my scalar value is positive, then vectors A and B point in the same direction. On the other hand, if C is negative, then A and B point in opposite directions. If I want to think about the magnitude, I'm not interested in the sign anymore. I really just want the absolute value of that scalar. If the absolute value of C is greater than 1, then that tells me that the magnitude of vector B will be greater than the magnitude of vector A. If the absolute value of C is less than 1, so sits somewhere between 1 and 0, then the magnitude of vector B will be less than the magnitude of vector A. If the absolute value of C is 1, then A and B have the same magnitude. So one way that I can summarize this is to say that the magnitude of vector B at the end of the day is simply going to be the absolute value of my scalar times the magnitude of vector A. So when I think about multiplying a vector by a scalar and think about how my new vector compares to the original vector, thinking about the sign of vector C will tell me about direction. Is it in the same direction or in the opposite direction? And thinking about the absolute value of C will tell me about what's going to happen with the magnitude.